Let's see now. I started recording. I did. Okay. Semantic kernel. So, out of curiosity, who knows semantic kernel already? Maybe you can send a reaction or you can send it in the chat. I want to see how what's the penetration is like for semantic kernel, especially comparing with other like prompt pro and long chain, sorry, who knows it. Nevertheless, that's not a big deal. Um, Many of you, most of you, most probably don't know me. I'm George. That photo is quite old, and that I see it. I should add a beer or something. Nevertheless, I'm a Microsoft MVP and organizer of this community here, and I work at Slalom as a senior architect. You can find me in those links over here, LinkedIn, GitHub, or georgecosmidis.net. But it's not very impressive. There's a few links to the GitHub, LinkedIn, and others. Let's see. Next one, change. So Slalom, I'm not gonna stay here for long. Just a small thing that I work for Slalom Germany, as I said, and it opened a couple of years ago, 2.5 years ago. Now it's not the latest market, but it was someday, and it was nice that we were the new guys. We have now other places. I think we changed for 46. Now it's 47 or 48. Most of these numbers are different now. The most important thing for me is that we are doing Microsoft projects already. We have a very good relationship. We're talking with Microsoft all the time. We are chosen for most of their Microsoft projects. That gives me the opportunity to get to know all these technologies firsthand, and also both because of the MVP and because of Slalom, I have connections to ask questions directly or even get private previews, which makes it very interesting about semantic kernel also. So Trim, if I'm saying the name correctly, is saying that it's been shown as a .NET focus, and it's indeed it's a nice thing. It's a good thing. I think it's important. I think you will like it. What is it though? It's a development kit. It helps you connect your code with AI. So right now we have LLMs that know natural language, and they work by exchanging prompts. And we have our code, our traditional code that is there, and we cannot very easily connect it to. So we cannot ask OpenAI, can you call a function that I have there and it's doing this and that? It cannot. Semantic kernel comes in between to cover this and information, meta informations to our functions, to our methods, so LLMs can call it in a way, can call them in a way. We'll see more details about that later. That is more or less what I was talking about, right? We have our code, pre-existing code. It can be Python, Java, and not .NET for now. Java is the latest addition. It was Python and .NET. We have our plugins. This weird atom thing in the middle is semantic kernel, the icon. We have our plugins. We'll see how it is. We have our hooks and filters. So how these three work with our code. And then we have all the latest AI models. And I mean I say latest because you can very well, now it's GPT 4.0. Tomorrow it will be 5.0. I don't know. You don't want your code to be to have a maintenance overhead in upgrading that version. Sorry. So here is where semantic kernel comes. It will be transparent. Now, this is a diagram. You can find it online. Also, I didn't do that. About what semantic kernel is. You have your application over here, and you need to somehow connect it with your AI, with your models on the other side. That could be OpenAI, Azure OpenAI, or Hugging Face for now. Not that many, but this is changing fast. And if you can connect it with Azure, Azure OpenAI supports many, many models. So you select your AI service, which one it should be. You're rendering the prompt. We'll see exactly how a prompt looks like, or the template, actually. That's why they are calling it templatization. And then once the template of your prompt and the values are grabbed by the kernel and they are rendered, we are invoking the AI service. We are getting a result back, and that result is parsed by Semantic Kernel, and it thus creates a function result, something that Semantic Kernel can understand in order to call your specific function in your code that does a traditional API call, I don't know, something. Basic concepts. What are the basic concepts of OpenAI? Semantic Kernel. I try to group them. You will find that all of those are different concepts, and you also have the AI as a concept, but this we know. Agents. This is a very general concept. This is, for example, a chatbot is an agent. An agent, you can, if it is about a bot that receives questions and answers to that questions, you can name it a chatbot. It's like a huge group. It's more or less your application or part of your application. Personas are the basic instructions of those agents, of a chat box, for example. It can help instruct the agent to ask a question if it doesn't know what to do. For example, I don't. You will see. We will see this specific example later on, so I can use that. Can you turn on the light? Which light? The office light or the kitchen light? Right? These are instructions that you're getting early on by creating an agent. And we'll use a predefined chat agent from Semantic Kernel, but you can write your own agents. Then we have the plugins and planners. Plugins are, let's say, the prompt templates, right? They are key components you cannot do without. For agents and personas, you can use the predefined agents and personas that come with Semantic Kernel. It more or less have a transparent experience. You don't need to do anything there. But plugins, unless you want something that it's out there already, you need to roll your own plugin, aka you need to write your own prompt. And planners are a way to connect those plugins. For example, you're asking a question to an LLM. If you go now to ChatGPT and ask a question, how many working days till Christmas? The LLM doesn't know what day is today, and it does know where you live. You live in Bavaria, and today is something mid-September. I don't even remember. So you can have one plugin that returns the location of the user that asks the question. For example, it's Bavaria. And you can have another function method that the semantic kernel knows how to call it and returns the current date, which is 23 of September, it's not mid-September. And you can have your plugin that actually forms that user question into a prompt. And you need a way to combine all these things. So your semantic kernel, or your LLM anyway, actually to be precise, semantic kernel, will first grab the time, then it will grab the location, then it will grab what you have asked, and it will combine all these into a prompt and send that prompt to the LLM you have chosen. Yeah, that's a planner. Sorry. And filters, these are just security. So you're asking a question and you have a filter that checks that question if it is within the limits that you decide. You cannot ask, of course, you cannot ask jokes that are racist, for example, but you might have also rules if you're building an agent, a chatbot for a company that needs to answer questions only based on only for Azure, and some user asks cloud-related questions, the LLM knows about the AWS too. So it shouldn't answer about the AWS, or the user should not be allowed to ask questions about AWS. So you're putting that filter in the middle, and when the user asks something that is not allowed, then you're responding, you shouldn't ask that, can you rephrase or something. Now, I added this slide because I know many of you will ask what's happening between prompt flow, LangChain, and semantic kernel. Where are we, and why should I use semantic kernel and not LangChain in prompt flow? There is no easy answer for that. Because if you use .NET, there is an easy answer. But if you're not using .NET, there is no easy answer. Especially if you're starting an application from scratch and you're like file new, then you can very well go to prompt flow and LangChain. They have a huge community, bigger than semantic kernel. Currently, they're supporting a lot more things than semantic kernel. But there is a catch there. It might never happen, but I think I should share it the way I see it. So if you know Jenkins, it's an automation tool for CI/CD. When it started, it was a very good tool because everyone could write kind of plugins, let's say, that would work with Jenkins and deploy and make your life easier. So suddenly you had thousands of plugins. More or less, they would do what you want. You want to grab the code from there, build it because it's Python, or I don't know, parse it because it's Python, run some linters, deploy it to another function. Someone would write how to deploy another function, a Python to another function. Someone would write how to run the specific linters for Python, and someone else how to parse it for whatever errors it might have. So you're bringing all this together and you're ending up with deploying something. And it was a very good thing because you could very fast do stuff. But then the problem started because when you are connecting components or these plugins that come from third-party users, you have no guarantee that they will work tomorrow. And you have no guarantee that if you upgrade the middle one, the one that runs the linters, because there is a security breach or something, it will work with the next one. So nowadays, when you're hearing Jenkins, you're like, oh my God, I hope they don't have Jenkins around, because it's such a mess to maintain it. And this is what's happening. It's not, no, sorry, I should rephrase it. It's not what's happening now with LangChain, but there is a sense we are going that way. There are tens of plugins available. Everything seems to work very well together. But if you start connecting all these plugins that people wrote, how do you maintain it? Yeah, thank you, Yosin, if I say it correctly, shared the open source, the semantic kernel, the open source. I will share that too because we'll also see the code that it's in there. We see a few things. Now, sorry, let me close my microphone so I can cough in peace. All right, thank you for this. Well, so let's see some code, right? Talking is nice. Let's see some code. I hope I can not stop staring. How can I stop this thing now? Get out of the presentation, please. Okay, here we are. Now, what Johan maybe shared, it's this repo. Let me bring it up here. Come on. It's this one. I think, right? The Microsoft one. This is semantic kernel. You can find the source code and everything you need, but you can also find lots and lots of examples, and you can find dev containers that you can start working immediately for each of it, for each case. You see that there it's a very, very active repo. There was a new push 1 hour ago that it's still pending. So things are happening. The good thing is that we are version 1 already. You can find it as a package, of course. You can download it directly, but you can also clone this repo, and then you will end up with this. So first of all, you have your repo here. I hope I still share my screen. I hope, if anything, please send a chat, a message. You have your repo. One of you things that you can do first is to download this extension here. You're typing Semantic Kernel, it's this one. You're installing it. You can see that this icon there when you install it. And then for your repo, for the repo that you have open, or for the folder that you have open anyway, it scans it and it finds all the available plugins. These are the plugins that they are pre-written by Microsoft for Semantic Kernel that you can use, of course, or either for experimentation, or some of them maybe for real application. For example, a calendar plugin that asks questions about the calendar and in requests to have the results in a specific format, and it also connects on specific functions to retrieve the current date time, as I said. Yeah, you can have the fun skill or maybe the fun plugin here that you can see what the prompt is, that it's pre-written. It contains two styles here, two input variables, one the style. So incorporate the style suggestion if provided, and that's the style. And another input that it's how the theme, what I want to have about my joke. Now, the cool thing is that you don't just see it. You could have that, it's a TXT, you could have that anyway, right? The cool thing is that you can press this button here, and then the first time you need to connect it with Azure OpenAI or OpenAI or whatever LLM you want. You will get a wizard, let's say, that will allow you, especially if you want to connect it with Azure OpenAI, you get the familiar screen to connect with Azure, and then you will have a list of all the OpenAI deployments to select one, and you can start using it. And now, if you have if you have that configured, like I have, you can write here, for example, style short joke, and input that one of year. Computers. Let's have a computer joke. And then in the outputs down here, you see that it got the prompts and it actually returned a joke, which is what did the computer go, why did the computer go to therapy? Because it had too many bytes from past relationships and needed to defragment its thoughts. Yeah, LLMs are so bad at jokes that, I mean, sometimes I wonder they grab this gazillion of data out there. How is it possible that they are good in so many other things and they are so bad at jokes? How are we humans so bad at jokes? I don't know. I have never, I tried that many times. I did that presentation, this presentation many times. I've never read a good joke. And you can also right click and debug the function, which is more or less the same. So let me try this. Maybe now I will have some nicer jokes. I don't have data. And you get additional information, especially if the plugin was calling other methods, then you could just jump into your method and see what was being called. And you're getting information here that I'm connected with Azure OpenAI. I'm with the GPT-4o model. This is the agent that we were talking about. So this is the agent instruction, the default one that we're getting by Microsoft. The instruction says you are an AI assistant that helps people find information. This is where you could have more instructions. If you don't know the answer, do this. And we're getting more in the prompt engineering stuff that it's not part of this presentation. It's executing that plugin, and this is the input. This is what it created as prompt at the end. Oh my God. I don't want to read it. So here's a humorous workplace story for you. One day, the office printer decided I had enough. It started blah, 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 printing random stuff. I don't want, there is no chance that this is a joke, but I can share it here and maybe you can tell me if it's funny. I can guarantee it's not funny. So This is how easy it is. Just downloading the repo that has prompts, getting the semantic kernel extension, done. Right? Now let's see a bit more in the code. This is what we'll see for now. It's Python. We'll first see Python, and then we'll jump into .NET also. It's a more interesting example. So if we go back to our code here, we get in the Python folder, samples, getting started. This is the getting started thingy that we're seeing now. What we are doing now is installing semantic kernel. We're using pip install. Now, about Python. I mean, I don't know where this thing came for Python, and everything needs to be written in Python. Python is, for example, in Azure function, in Cloud function, in Lambdas also, it's 2 times slower than Node and .NET. So I don't know why everyone suddenly loved Python. I guess it's like the new JavaScript thing. You can write whatever you want, loosely coupled, no errors while there is no compilation. So of course, no errors. And you deploy it and you're getting your surprise in production if you test that specific part. So I don't know why this frenzy, but it seems since it makes sense to have some very at least superficial understanding of how Python works, set up a project, run it, understand the syntax, because it's everywhere and we don't know if it is truly going to be the new JavaScript. I wouldn't be surprised if we see it in a browser at some point. So we installed semantic kernel. You see that all requirements are already satisfied because I've installed it and I played around quite a lot with Python the last days. This is the version, because we are asking for the version down here. This is the version that we are using. As a next step, now this is very specific to this Jupyter notebook. Another thing about Jupyter notebooks, very cool for presentations and very cool to explain to others, and also leave documentation for, like instead of readme file, you can leave that, and it's very cool for the next developer. So around that just sets the paths in my the system paths, the grand parent dir. Why? Because this is all the code, where the code is, and all the prompts and stuff. This is very specific to this presentation. The next thing you should do, or the first thing you should do anyway, is configure the model that you will be using. This specific notebook is with OpenAI or Azure OpenAI. You can find others with Hugging Face. If I remember correctly, the last time I did that, although I got a new update, was with Azure OpenAI, but we'll see that. We're creating an instance, we know what that is. And then we are getting the service, the selected service. We are registering the selected service, which is Azure OpenAI. I hard coded this. I remember this change. So it is indeed Azure OpenAI that I have now as configuration. The next step, this is what we care for. This is for OpenAI, and this is for Azure OpenAI, more or less the same, as you will see. This is our agent. This is one of the defaults that come, the Azure chat completion. If we go here, you see that it's coming from semantic kernel in here. So it's their packet, let's say. And it comes with pre-configured some of the stuff that we might need. So the basic instruction, I think it should be somewhere here. All the failings, let's see if we can find also the actual instruction, maybe not, but that's okay. So it's a pre-configured agent, let's say, from that comes with semantic kernel. Did I run that part? I don't know. Let's do it again. So we are here. And then last part. So we set up our environment. You can grab all these pieces of code and have one Python script to run all of them in one go. The last part, we are grabbing a plugin that we already have. This is 3 folders back inside the prompt template samples in this repo, and we're running this specific plugin. So 3 folders back and the prompt template sample record, folder. We're going here, fun plugin. This is the prompt that we were seeing before, but we also see now the configuration. The classical one, you need to have the max tokens. You can actually make it smaller, so maybe you don't have to read that much. Temperature, probability, presence, penalty, all that stuff that we know, or anyway we've heard, and also the registration in a sense of the input variables. We have one named input and another one named style. So we grab that here as a plugin. We register that plugin here and we are invoking it. Yeah, so we run it here. Apparently, an amazing joke will come up again. Why did the time traveler bring a ladder to the dinosaur age? Because he heard the dinosaurs were a little over his head. Yeah, Super Silly is not describing it very well, actually, but anyway, that's it. No more Python. I mean, it's a thing, but I don't think we should dive any deeper into Python. It doesn't make sense. But I think this getting started notebook gives you an idea of how plugins work, which is the only mandatory thing that you should know. And then we can go to something more interesting. Any questions up until now? I can drink a sip of water and we can continue. Although we will have some time in the end, probably. But yeah, if you have any questions, the icons I like, at least that joke had something that I like. So let's go to .NET. As you can see, Java supported, they only have this readme file that changed at some point, and I was surprised that there is another repo if you want to play semantic, if you want to see semantic kernel with Java. Let's jump to that repo. We won't see it now. Maybe we'll see that repo later on if we have time, because I haven't seen it yet. But let's go to .NET right now. Yeah. Now, one of the value propositions, and where is my example? It's here, isn't it? Yeah, it's here. One of the value propositions of semantic kernel is that it can be very effective in code that it's already there, to use it and integrate that code with LLM and actually enhance your application and have LLM support. Now, what that does, and I need to go to that folder now, which is, I think I can also be fast and do this and open an integrated terminal. That it should be deactivated now that I left, but anyway. So we are here, right? Yeah. We can run .NET Run to see how that looks like, first of all, and then we can navigate through the example a bit, because I think that you will find it very interesting. What does this part, this sample does? It pretends it's a home automation application. You could very well have it already, and now let's assume that you want to enhance it with AI. So add this capability and have the ability to actually chat with your application. Yeah. Let's see the examples one-to-one. What time is it? Why is it a complicated question? Because LLMs don't know the time. So what's happening now, it is fetching a piece of code that can return the time. This is fed then to the LLM, so the LLM knows the time. If you go to the My plugin here, just this piece of code, forget that one. This is the code that you have. The only thing that you did to make it LLM callable, if I may say, besides adding semantic kernel, of course, to your project, is add this line here. You're saying that this function over here, this method, is a kernel function, and the description of that method is get the current time. This is what semantic kernel means. It adds semantics to your method. And since you have that, whenever you're asking for the time, the LLM knows which method to call to get the current time, which is fascinating how it's happening on the other side. If you're interested, you can take a look. Now, see what other stuff we can do here. Set an alarm for 6 a.m. What does that mean? To set an alarm before or for X 6 a.m., it needs to know what time it's now. Yeah. Let's see the result. Your alarm has been set for 6 a.m. Let's see what that plugin does. Slowly we'll get to even more complicated plugins like the My Light plugin. So that plugin sets an alarm. You can have your code here that actually sets the alarm. But we also inject into that class the My Time plugin. And forget this kernel function. Again, it is the code that we know. You are doing a dependency injection, nothing more, nothing more. And from that, the LLM understands that there is a My Alarm plugin related. It calls, My Time plugin related. It calls the My Time plugin, gets the time, and use it somehow here, your code to set the alarm. Yeah. And now let's go to the My Light plugin, which is a bit more complicated. Let's say I will remove that from the previous presentation. This is a spoiler. It was a spoiler. We'll do it together. So let's assume and let's say you have this stuff here. This is your code, your IoT code, wherever you have that actually turns on the lights, and then it checks if the lights are turned on. You're going to your program CS and you're registering a key singleton for the office light. You have two lights, the office light and the porch light. You're registering those. See right now, no kernel, no semantic kernel, nothing. That's what you have been doing already in your code. You're registering the two plugins, your two classes. Actually, they're just classes. And specifically for one, you're also saying that it's turned on, the light, nothing else. You do add the plugin in the plugin collections, all the stuff that you want with just a kernel plugin collection. This is the only difference. So this is how kernel knows that these things are there. And then you're going back to the My Light plugin and you start decorating everything with the kernel function that we're discussing. So represents a light, you can turn it off and change this color. You cannot. Well, let's do that later. We have time. I think we can have some time to play. Right? Nothing peculiar here. We just decorated this My Light plugin with descriptions that give some meanings to the semantic, to LLM and the semantic kernel on what each of those methods do. And what we can do now, we can actually rerun this because I don't know how dirty it was from my previous presentation with the colors and stuff. And we can ask, can you turn on the light? Remember, there are two lights. So, sir, which light would you like to turn on, the office light or the porch light? There are no prompt engineering here describing that there are two lights or stuff. There is only this thing here and the registration that you did here. So the LLM or semantic kernel instructed the LLM that there is a light plugin, there is a way to turn on the lights, but there are two lights, the office plugin and the porch plugin. Which one do you want to turn on? You can say, oops, no, sorry, undo that. Oh, sorry, can you turn on the office light, please? And now it will run again. The office light has been turned on. If you need any further assistance, blah, blah, blah. Again, no prompt engineering. You just decorated your functions that are already there with this line. You're done. AI enabled or LLM enabled. And imagine now this. You have on the other side text to speech or speech to text, sorry. And you have a microphone. You're saying, turn on the lights in the office, please. This is returned as a text. You're sending this to semantic kernel, and your office lights are on that easily. So how do we extend that? I mean, we can see this example, unless you have questions or you have any ideas on what other stuff to do. We can definitely do that. On the other hand, since this is a .NET Meetup, I assume just by seeing that, you know how easy it is to add new functionality. But let's see it together. And let's also try to actually do it instead of me copying it. I think I have it here. Instead of me copying it, let's try to do it here because we can see some cases that just doesn't work and we can debug them together. Am I writing? Yeah. So we can write a plugin string get color. Let's make it more descriptive. And you can have here the color string, color, and so all of that is actually not necessary. Semantic kernel piece that makes it look nicer. This is though, let's make that yellow so we can know who won. Yellow. And so that should be that. Yeah, and that should be that. So of course now use properties where appropriate. Okay. Yeah, whatever. So of course now semantic kernel doesn't know it. We need to decorate. So if we run this thing now, we will get nothing for colors. We run it. Can you change the color in the light color to later get crazy and do something crazy or ask that it appears that I can only turn the office light on or off. Changing the light color is not within the available functions. So it doesn't see a function that can do that, right? Good. Sometimes though, I mean, not very often, but sometimes I've seen some weird results, like asking that, and since it doesn't know the function, it says the time is 6:03 or something. This is weird, but I guess this is within the probable errors an LLM can do. But one thing that we can do before adding a description, let's try to, oh, come on. Let's try to just decorate it with semantic kernel. You see, that's Copilot, also an LLM. Thank you for that, but I don't want this thing here. Let's remove the description. Can I? I don't even remember. Yeah, whatever. So we mark it now as a kernel function. Let's see what it does now. Come on. What color is the office light? Let's see now. The office light is yellow. You see, I didn't add a decoration, but what semantic kernel does is also including in all this complicated prompt that it creates on the other side, a function name. So just by that, if I have my function names, my method names correct, or my properties, it knows what to do. And let's make a funny experiment now. Let's have a description here to see who wins, right? Let's have a description here, returns the size. Oops, size of this light. I have no idea, but maybe both, maybe none of them. Maybe sometimes you will get the color and sometimes you will get the size. This is then creating a wrong prompt. And so, yeah, the LLM has every reason to get crazy. What color is the office light? And what size? Size is the office light. Size typically refers to dimension, but it seems the query has returned the color information instead. This is an error in a sense that, but it describes what happened. So it's very interesting. If you meant something else by size, please clarify. So it did something, right? And you can continue playing with that. Now that you got the message, the idea, you can have a color here, so you can create the correct prompt. Although this works, it's not advisable. Probably within a bigger project, you will have many methods that might have a similar name. You wouldn't want that to happen. But you can have also a public void set color, and we are passing here this one. Is that correct what I'm doing here? I think it's correct. Yeah. Color. That's color. And this is the semantic kernel. Changes the color of light. Now, I mean, the presentation should be slower, but sometimes Copilot is very annoying because it writes all this down, and it's like I have 20 minutes, and see how fast you write with Copilot. And save that. Let's rerun it, and let's also play around with the program CS here. I think I did it, or did I not? We can have here that the ports light, oops, color is not yellow again. Let's have it now white. So here we have it white with, for the ports light, we're passing it as white. Here we're passing it as yellow. That would be the office light. And any other predefined value, nothing. That's it. So let's see if it is what color it will be. .NET run. Wow. Let's what is the colors of the lights? Actually, I haven't tried that again. The office light is currently yellow and the port light is white. So we get both. And it is correct. The office light is yellow because it grabs that, and the port light grabs that, and it's red. But if I right now, can you turn can you set, I don't know if someone that knows better English than me, can you set the office light to red and the ports light to blue, please? Let's be polite. You never know when they will actually conquer the world. Both office light has been set to red and the port light has been set to blue. So what colors are the lights? The office light is set to red and the port light is set to blue. So you see how much possibilities there are here. Not changing every light, every light, yeah, at the same time, or one by one, let's say, but you can change both at the same time, or you can combine more commands. Probably. Let's test that. Can you set an alarm for come on, 6:18 anyway, and the office light color to green. I think I never used that. The alarm has been set to 6 and the office light color has been changed to green. So again, this is not the LLM talking. Commanding kernel is actually calling then these plugins here to get the color. Yeah. So there are 15 minutes more for this presentation. I am almost near the end. We can return back to the slides. Just to show you one more slide, and then we can discuss a few things. That's one more slide, nothing scary. I don't like slides also. I find it more boring than actually doing code. But sometimes you have to. And let me start the slide stuff again, Shift and F5. So what's the value proposition of semantic kernel? I know with LangChain and prompt flow out there, you need to have a very strong value proposition. For you that you've seen it working with .NET and you are .NET engineers or anyway engineers, You've seen it. You're getting your code as it was before, just decorating one line, done. You created a smart AI. That is invaluable. Nowadays, everyone wants to get on board the LLM train and they don't know how. There is an easy way. Just use the code that you already have. If you have .NET and Java and Python for now. So seamless integration with .NET. This means that it's designed to integrate easily with existing .NET applications. I don't know what's happening with the Java world. Maybe this is another meetup that we can do. But with .NET is ridiculous. You just add it, and also Visual Studio Code is helping you that much to actually do semantic kernel. The entire Microsoft ecosystem right now is looking at LLMs and every tool that it's AI related. So there are lots of money going towards that way. Rapid AI enhancement, that's what I said before, and that's what we saw. You're getting your existing .NET application, you're having a smart application already. And as I said it at some point, imagine adding speech to text capabilities and text to speech. So you have a smartwatch that you're clicking. I have my robot here that cleans the house. And I have an app in my phone that I need to click the app. And so I sent the vacuum, the robot vacuum of how it's called, to clean that place over there. It would be so easy if they used .NET, I don't know what they used, to just decorate the function, go there and click that place with semantic kernel, and use Azure text to speech and speak to text. So from next morning, I could say my vacuum robot, go there and clean that, and that's it. So it's super. Modular and extensible architecture. So this is so modular because of the plugins, of the agents, of the planners, all the functionality that we saw, and even more because it supports automatically more and more models as they come out. Now we are stopping at 3, OpenAI, Azure, all the AI models that Azure has, which there are a lot, and Hugging Face. But there are more coming, and actually more versions of those coming. So you don't need to do anything. Just go there and say, you know what, I want to use GPT-4o. I want to use that deployment. Done. You change nothing else in your code. You're just change the pointer to the LLM deployment, to the appropriate one. Dynamic task planning and orchestration. This is more or less what we spoke. We didn't have time to get deeper into that, but this is also very, very interesting. More or less, we saw it here, how easy it is with my alarm, how easy it is with .NET. You're using dependency injection, and now your alarm plugin knows about time, and it knows how to call semantic kernel to grab the time and then use it in here. So it's that easy. We'll have a meetup just for that because it's super cool and interesting. How can I go back now again? Shift F5. Microsoft ecosystem integration. Yeah, this is more marketing things, but they are cool. The Visual Studio Code extension that you just click and you debug your plugins directly there. You can debug more also skills and plugins. We'll see all of that details in another meetup. And then it is, of course, open source. And you have a community supporting it. Not that big as you would see, for example, in LangChain, but it's big. And it's, for me, sometimes it makes sense to invest in things that there are billions on the other side investing also. And right now, Microsoft and everyone, like AWS, for example, I know Google, they're investing billions into that thing. They are so they have such a huge energy requirements. I've read somewhere that Microsoft is buying a nuclear plant, plans to start it just to have their own energy. I don't know how much that investment is pays off now. I guess they planned that this would pay off in 10 years, maybe something like that. Let's see. But there is a huge investment, and investing in solutions or developing kits that they are based in communities, that's good as long as there are some standards to follow on how to create those plugins and those extensions to bind everything together. It's like the Jenkins example that I said before. If you have some standards and you cannot just publish anything, something that breaks a functionality without versioning on us something, then you are in big danger. Anyway, that was the presentation. Let me go back to this one, or I can also go to this one, because you might want to reach out if you need anything. There is Trimi saying, I suppose we can use Semantic Kernel in conjunction with Microsoft 5.3 Cookbook. Yeah, you can do that. You might, I mean, you're diving deeper into that, and that's super cool. We haven't seen that, but you can actually write your own. I don't think is that called plugins or extensions. So right now we have OpenAI, Azure OpenAI, and Hugging Face. You can write your own extensions to talk with your LLMs, and maybe I can open and sell that instead of my face, which I don't look like that anymore. Anyway, yeah, if you want to get deeper, I don't think I would get any deeper right now. Most of the times the goal is to have something that you can sell, and what you can definitely sell is rapid AI enhancement. If you have your code, just change it like that. You don't need to do anything. You don't need to re-educate your engineers. You don't need to invest in rewriting stuff. Just decorate it and you're done. But there is a lot of meat here, and there are a lot of stuff to discuss. Yeah. And Tim, if you are updated or you know about that, I would be happy if we can create a new meetup and you can introduce us in all these things that I see here and I haven't had time to actually check. Yeah. If you're running air gap, you need to run an LLM locally though. Yeah. I mean, someday you would run LLMs like 5 of them in our mobile phones. Now they might want a nuclear plants to train them and run them, but I guess in the future it won't be so demanding. Anyone, any other questions? Because there is a high chance if there are no questions, I can give you 5 minutes back of your life and time. All right. Thank you, all of you. Thank you, Tim, for your nice comments here. I reach out if you're interested in contributing to the semantic kernel revolution and actually help out with the local LLMs and how to run them. That would be super interesting too. If you have any ideas, ping me. If you have any ideas for a meetup, if you want to talk, organize it offline. Organize it. I mean, in person or virtual. Ping me, and we can very well do it. Yeah. Thank you for your time. I hope you will have a nice week ahead. And up until next time, ciao. Bye. Bye, Dean.